My name is Ben Thurgood. I'm a solutions architect from Sydney, Australia. And this is scaling up to your first 10 million users. Does anybody recognize this game? Yeah? Australian rules football. So let's talk about your goals, or the goals for this session. Who has a web application that they're building or operating today? Lots of hands. And who has thousands of users? Yeah, quite a few. What about tens of thousands? Oh, still quite a lot. Hundreds of thousands? Cool. Millions. Wow. Tens of millions. Okay. Make sure you take note of those hands. They've probably got some good tips for you today. Might speak to them myself afterwards. Today we're going to go over the capabilities of the AWS platform that's going to enable you to scale no matter where you are on that spectrum. It's a 200-level presentation, and it's quite broad. We're going to cover a lot of material. So scaling on AWS. Well, you've done a great job on your application so far. Unfortunately, that means you're going to have to scale. That's great. Scaling is a high-value problem to have. Now, you may find that you have to deal with sudden increases in scale, like one of my customers whose request volumes doubles every year in September, and that's become their new norm every year for 4 years. Great problem to have, really. Or you may be experiencing steady-state growth, constant growth. Either way, what I go through today is going to help you to deal with that. Now, if you want to know about something, if you're like me, one of the first things you do, look it up. Scaling on AWS. You're going to get a lot of hits and a lot of references to auto-scaling. Now, that sounds great, doesn't it? Turn that on, auto-scaling. Pretty much done. Unfortunately, it's not the one thing that fixes everything, and there's a lot of other things we need to go through today in order to scale successfully. We'll get to that, though. So what do we need to do first? Let's cover some basics. One of the first things you'll use to help you scale is the AWS Global Infrastructure. We have 16 regions around the world, and more to come. And in each region, we have multiple availability zones, each isolated from one another in terms of power, internet, geographical risks, yet close enough together to enable single-digit millisecond latency. And what that's going to enable you to do is things like synchronous data replication, which you'll see will come in handy. We also have over 100 edge locations where you can cache your content close to where your users are, offloading load from your servers. It's going to help you scale as well. Now, AWS is one of the most robust, fully featured technology platforms available. And there's many applications and services available in so many categories to help you do what you need to do. Now, it's not to say you need to use all of this in day one. More to say that these facilities are available to you as you go on this journey. And when you find you need a feature or a capability, look into what the AWS platform has to offer and take advantage of that so you don't have to reinvent the wheel. Now, AWS services come in two flavors. Those that are managed by AWS on your behalf, and those are inherently highly scalable, highly available, and fault tolerant. Straight out of the box. You just use them, and they'll do that for you. Things like CloudFront, S3, Lambda, which we'll cover today. And then there are other services that can be highly available, highly scalable, and fault tolerant, depending on the architecture that you use. If you architect them right, you can absolutely do that. Things like EC2 and relational database service. So some considerations before we begin. Scaling on AWS is an evolving story. We've given this talk at reInvent every year, and the reason for that is the concepts we go over are fundamental to the value proposition of the cloud. Now, I'm going to talk about a linear journey starting from the beginning of an application all the way up to 10 million users. But depending on where you are today on the journey, you may decide to skip several of the stages that I talked through, or you may decide as well that you want to go over the top and go to a more sophisticated architecture much earlier on. And these are trade-offs that you'll need to consider. You could spend more time engineering at the beginning. That's going to take away from the time you're going to spend building functionality into your application for your end users. So these kind of trade-offs are what you need to decide as a team. Whatever you decide, most of these decisions will be two-way doors. They'll be reversible. And a lot of what I talk about today will be refactoring your application in order to improve it as we go. So the most important thing is that you just get building and learn from the experience of helping your customers use your application. So let's start from day one. In the beginning, it's you, developer of your application. What do you need to get going? Well, you're going to need an EC2 instance, something to build your application and run it on, IP address, domain name, Route 53. Now, one of the easiest ways to get going with that is Amazon Lightsail. This is a super convenient and cost-effective way to get started on AWS because it gives you access to those types of features without you having to know all the ins and outs of the AWS platform. And it's really easy to burst out from there and use more fully featured aspects of the AWS platform as you go and you become more comfortable. Now, whether you use Lightsail or EC2 directly, one of the first levers you're going to pull from a scalability perspective is the type of EC2 instance that you use. We have many different types of instances in terms of some being more memory intensive, CPU intensive, IO intensive, we have GPU instances. So depending on the characteristics of your application, the type of instance you use, and then also the configuration options that you choose on an instance will affect its performance. And you can change that as you go. And the other thing is you can change the size of the instance you use, adding a bigger machine to scale up and support more volumes of transactions. And you can do this anytime just by stopping your instance, changing that configuration parameter, and then bring it up again. Now, I can give you, or we can give you, instances with hundreds of CPUs and terabytes of memory. But no matter what, you're going to hit an endpoint eventually. And can anyone else think of a problem with just having a single instance as your architecture? Probably. No failover, exactly. So no redundancy. So this is one of the first things we're going to have to deal with in our architecture. But before we do, we want to get beyond one user. One of the first things I'm going to suggest we do is separate our web tier from our database tier. And this is a constant principle we'll come back to over and over again. There'll be a few of these principles we go through today where we're separating out aspects of our application so that we can operate and scale them separately. Because the amount of load on our web tier might be different to the amount of load on our database tier and vice versa. And we want to be able to operate those things independently. Now, if you're going to choose a database, you've got a few options. You can simply put the database on the same EC2 instance, same type of EC2 instance or another type, and you can pretty much have any database you want. Now, the catch with that is you're going to have to manage it. You're going to have to patch the operating system, the database, do the backups, and those tasks are going to fall to your team and take away time that they would otherwise spend doing stuff on your application itself. So another option is to go for a managed database. So Amazon Relational Database Service gives you access to many open source database engines like MySQL, Postgres, MariaDB. You have Amazon Aurora, which I'll mention in a minute as well. Proprietary engines like Oracle and MySQL, and Microsoft SQL Server, I beg your pardon. And also mention Amazon Redshift, which is our petabyte scale data warehouse. Now, you may not use this at this stage in your application, but it's something to be aware of because later on, you can offload your analytics and reporting to a data warehouse to take away pressure from your transactional systems. So let's take a look at Amazon Aurora. So it's a MySQL or Postgres compatible database. And it's the most popular services, and that's because it's incredibly cost-effective, but it's also really highly performant, about 5 times the performance of what you'd expect from a similar MySQL database. It also has this great feature that enables you to automatically scale up your storage. This is going to come in handy as you get bigger and bigger. It allows you to have 15 read replicas, which you'll see why that's handy in a minute. And it's backing up your data 6 ways across 3 availability zones constantly. Now, another decision you're going to have to make is whether to go NoSQL from the beginning. Now, NoSQL is really popular today, and it's very common for us to choose NoSQL early on. We'd actually recommend that you start with a SQL database. Now, the reason for that is it's a really established and well-worn technology. There's lots of existing code, communities, books, tools available to help you, and you're really not going to break this technology in your first millions of users. There's clear patterns of scalability for it, which I'll go through as well. Now, the caveat here is, unless you're doing something quite particular, and that could be if you've got lots and lots of data, for example. Now, if you thought, oh, that's me. You said it, lots of data. Let me just clarify what I mean. I'm talking about 5 terabytes or greater in a year, or a really data-intensive application. Then you might want to consider it. Other reasons you might want to consider it, if you have super low latency, if you've got very metadata-driven data sets, you want to have schemaless data. Now, keep in mind, we're not just talking I want to have schemaless, but actual requirement to have schemaless. Then these are some of the reasons why you might choose NoSQL early on as well. Another thing you're going to have to solve when you get past 1 user is registration, sign-in, all the use cases that go with having more than 1 user. And if you're like me and you've built lots of web applications in the past, you've built these stories over and over and over again into your applications. Now, you could do that. Or another option is you could take advantage of an Amazon service called Amazon Cognito, which enables you to build that functionality into your application really easily. Gives you sign up and sign in, multi-factor authentication, a whole range of different features that you'd like to have. It also enables you to use federated identities with popular identity management systems. So that's an option to consider. That's going to start us towards the journey of aspiring to hundreds of users. Now, if we're going for hundreds of users, I'm going to recommend that you use the relational database service. And we've got a master database here. It'll become apparent why I'm suggesting that as we go through. But one of the first things is, as I said, it's going to take away that load from your development. So now let's go towards 1,000 users. Well, one of the first things we're going to do in terms of scaling as we get a little bit bigger is use that other lever we have with scaling, which is scaling horizontally. So now we're scaling across those availability zones I mentioned earlier. Here I've depicted 2. Whenever I'm depicting 2, I'm really saying across multiple. So this could be across as many availability zones as you have available in the region you're deploying into. And you're going to scale horizontally to support the number of users you're seeing and the load that's happening on those servers. We're also using a feature of the relational database service now to have a slave database in one of the other zones. And this is going to synchronously replicate data between those availability zones, keeping that data up to date for us. So that if we have a failure in our master database, the relational database service will automatically fail over to that slave for us. Now, we're able to load balance between the different web instances using a load balancer. And that's enabling us to be able to scale out horizontally. When choosing a load balancer, we have a few options. We have an application load balancer, a network load balancer, and a classic load balancer. Now, you're going to use a classic load balancer if you're dealing with a classic EC2 classic network. Most of you will probably have a VPC, in which case we suggest you use either an application load balancer or a network load balancer. The application load balancer has a really helpful feature which is to keep a health check of your actual servers. So if there's any problems with your servers, it'll detect that and it'll stop routing traffic to it. Now, the application load balancer is what we'd recommend for web servers, for web applications. And that's because it's routing traffic at layer 7. So you can do things like content-based routing and advanced features like WebSockets. Now, if you need to route at layer 4, or you've got extreme performance requirements, ultra-low latency requirements, you might want to consider the network load balancer instead. So this gives us those two levers, as I mentioned, scaling horizontally and vertically, that we're going to keep coming back to as we scale up and our volume is increasing. We're going to continually revisit these capabilities. Scaling up vertically by using the type of instance, and scaling horizontally by adding instances into our system. That basic architecture is going to take us to the ability to deal with hundreds of thousands of users. And it looks something like this. We're going to scale out increasingly across our availability zones with a number of web instances to support the number of requests we're seeing. We'll also use another feature of the relational database service. Some of the engines available on the relational database service allow you to have read replicas. Now, read replicas allow you to offload the read requests from your web servers from your master database. So again, another principle we'll come back to is spreading the load across multiple components of your system. Now, we can spread the load around even further. We can take the static content from our web instances and serve that from Amazon S3. So those static web pages actually host them in S3. And we can do that, and we can put Amazon CloudFront in front of that to cache that content close to where our end users are, reducing the latency that they experience. So let's have a look at those. S3 is one of the most underrated services available on the AWS platform. And it's one of those services that you see on architecture diagrams. Almost every architecture has S3 in it. And that's because it's so durable. It's designed for 11 nines of durability. Now, that means that if you have 10,000 objects, you might lose one of them after 10 million years. It's pretty durable. It's also infinitely scalable, both in terms of the storage capacity and request volumes. So that's just something you don't have to worry about. If your static content's there, it's just going to handle it. The other service that I mentioned is CloudFront. Now, this is our content delivery network service, where it'll cache the content in those edge locations I mentioned earlier, so that it's closer to wherever your users are requesting that content from. Meaning that when that content is requested again, it's cached close to that location, and your users don't have to take that extra hop and come to your web servers. They can, or S3, they can just get it from that edge. You can also use it to speed up your dynamic content, because it'll optimize the route to your dynamic content. And we can see here that using a content delivery network, we can actually reduce the latency in our system. We can reduce the response time and reduce that server load, because every request that hits CloudFront doesn't hit S3 and doesn't hit our web tier. So our server load is going to be much reduced. This graphic down at the bottom of the screen is showing one of our customers who experienced a scaling event. They were ticking away at around 5, 10 gigabits per second, and they suddenly had a request volume jump up and spike to around 80 gigabits per second. Now, the interesting thing about this is they were able to support that request volume without doing anything in their system. Their web tier didn't actually see any of that load. This is incredibly powerful capability that you have access to if you put this into your applications. Now, we can shift the load around even further. We can cache our requests to our database using Amazon ElastiCache. So this is a managed Memcached or Redis cluster. It'll scale up to many nodes, as many as you need. It'll heal nodes that fail, replace them, and it's going to give you single-digit millisecond speeds. Another way we can shift a load around is by moving our session data into a NoSQL database. And we could use Amazon DynamoDB for that. So Amazon DynamoDB is the managed NoSQL database. It allows you to scale your throughput, whether it's read throughput or write throughput separately. You can set that to whatever level you need it to be at, and it will even auto-scale that for you. It's fully distributed and fault tolerant. It's going to scale for you, and it'll support JSON, items up to 400 kilobits. Now, one thing you might want to use when you're looking about moving your data around, and we'll talk about refactoring your application as we go, you're going to need to move your data around the system between different places as you start to refactor. And one of the ways you could do that is by using the AWS Database Migration Service. Now, using this service, you can point it at a source database, and it will replicate that data to your target database without affecting the performance of your source database heavily. So you can even do this in production. So you can have the data replicate across, and when you're ready, you can switch that to be the primary store. There's also another service, Amazon DynamoDB Accelerator, and this allows you to cache the content, cache the requests for DynamoDB. So this is going to further increase your read performance on DynamoDB, and it's going to lower the cost because you don't need to provision as much read throughput on your DynamoDB in that case. At this stage, architecturally, we've actually lightened our architecture, lightened the load across our service. We've spread it out. So this is going to enable us to revisit something we talked about in the beginning, auto-scaling. So this is a typical weekly traffic at Amazon.com. You see it peaking during the day, dropping down in the evening. Hopefully people are taking a bit of a break at night, going to sleep. Now, if we were going to provision capacity to support that, we'd want to have a margin of safety above that. You might argue that this is actually quite a conservative margin of safety. We might have even had double capacity in the old days. But what about in November? What about this month? The traffic steadily increases on Amazon.com until the end of the month we see these big spikes for Black Friday and Monday, so yesterday. Now, if we were going to provision capacity with margin of safety on there, we're going to have 76% of our provision capacity unutilized for the month. That's not a great position to be in. What we'd really prefer is to be able to provision just enough capacity to support the load that we're seeing and reduce that capacity whenever we're seeing that load come off. Now, auto-scaling lets us do this, and it does it automatically. The way it works is it lets you specify a minimum and a maximum pool size, and then it will automatically scale your cluster to support the volume that you're seeing. It's really easy to define an auto-scaling group. You can see the command example down the bottom. And it will scale your cluster dependent on CloudWatch metrics that you set. Okay, so you can set a metric to fire an alarm to say whether your CPU is getting too high or you're seeing the request volumes get to a certain level, and then it'll automatically add an instance for you. And that can be across multiple availability zones. And then when it sees that capacity dropping back off, another alarm will fire and instances will be turned off, and it'll scale back down automatically without you having to do anything. Really handy. So now we've incorporated this type of architecture, we're going to be able to support upwards of 500,000 users, getting into the big leagues now. We're scaling out using our load balancer. We've got offloaded content, static content on S3. We're caching. We've got our session store in DynamoDB. We're using read replicas. We've got our standby database, multi-AZ feature of relational database. And now we've got auto-scaling across our availability zones. But what I prefer is to actually auto-scale automatically across multiple availability zones, just define my auto-scaling group to just provision those instances in whichever zone it is next on the list, and just keep provisioning out across. And that's going to add resiliency into our application as well. So if we haven't already, we've done some automation by using auto-scaling groups. We've automated part of our application. And I would say that the first thing we should be looking at in our architecture is using something that's managed for us, so we don't have to do it. But if we are going to have to do it, then the next step I would go to is try to automate it. So if you haven't already at this stage, we're starting to look at automating the infrastructure and the provisioning of our systems. And AWS provides several services to help you do that, ranging from really convenient ones to more complex but highly controllable ones, give you a lot of control. So at the convenience end of the spectrum, we have Elastic Beanstalk. Now that's a great service where you can just point it at your code and it'll provision the AWS resources that are necessary to operate your application on. Now, if you want more control than that and you like configuration management, AWS OpsWorks gives you the ability to use Chef or Puppet to describe what you'd like your instances to behave like using things like Chef recipes, and it will handle provisioning those users and configuring them and keeping them configured to the way that you need them to be. Now, going further than that, giving you even more control is AWS CloudFormation. Now, you can use CloudFormation to declaratively describe what your resources need to be in either JSON or YAML. And it's smart enough to be able to provision those resources for you and in the right order. And if you change your template, it will be able to know exactly what it needs to change in order to make that work. It'll also do rolling updates for you as well. Now, if you want even more control, all of the AWS services have an API available to you. So you can actually automate it anything you want. You can make it work the exact way you'd like it to by using the CLI, the command line interface, or the SDK, Soft Development Kit. Now, at this stage, we're actually treating our infrastructure as code. We're defining the resources of our application in code. And as we'd like to, with our application, to have continuous integration and continuous delivery for our application code, we'd also like to do that with our infrastructure code. So AWS provides some services to help you do that as well. We have AWS Code Commit, which is a Git repository where you can store your infrastructure code and your application code. There's AWS Code Build, where you can build your application. It's on demand. You pay only for the build time that you use. You can use third-party tooling to do testing. And of course, you would actually want to test the scalability of your system. Just like you'd want to test the security and the functional requirements of your system, you'd want to test that scalability. And when it comes to deploying, AWS Code Deploy lets you deploy to thousands of instances. Now, you can orchestrate all of this using AWS Code Pipeline. It'll actually be able to be triggered by your code being checked into Code Commit and start a pipeline off of building, testing, and deploying your system automatically. So these are really powerful features that you have access to. Now, you will need to actually implement this pipeline and build out these features using these tools. So whilst it's very powerful, it's also something that you need to do. Now, to get started with this, a really easy way is to use another service called AWS CodeStar. CodeStar, you can think of it as like the light sail of CI/CD development, because it lets you start with a template for a given application, and it'll put all those building blocks in place for you and enable you to get started really quickly with that style of development. Another thing that you want to do at this point, if you haven't already, is build monitoring and metrics and logging into your application. Now, this isn't something that you want to actually build yourself. Just utilize the services provided by AWS things like CloudWatch, or there's lots of services provided by our partners as well. So the sorts of things you want to log and monitor, things like host level metrics to see where are the hosts' CPU and memory and all of those types of things, how are they performing, make sure that that's all going well. Aggregate level metrics like your response times, etc. Log analysis so you can deep dive into any issues you're having and detect any errors that are occurring. And of course, it's great to know how your application is performing on the inside, but what's most important is the experience that your end users are having. So another thing that I wanted to call out with respect to monitoring and logging is a feature in CloudWatch called CloudWatch percentiles. One of the problems with always using averages is it can hide anomalies from you. So it can give you a false sense of security. Using things like P90, which is to say that the data for this particular metric, all of it falls below, if you say at the 90 percentile, 90% of it falls below that mark, or P99, 99% of it falls below that mark. This will enable you to see where you've got anomalies in your system and dive deep and find out what's actually going on to improve the performance and operational characteristics of your system as you go. So we've looked at the architecture of our system so far to improve it. Let's look into the application itself and see what else we can do. Now, I've assumed at this point that you've built a monolithic architecture. You may have chosen to break this down by now, but if you haven't already, you've got a monolithic architecture, you've got your user interface, your business logic, your data access, and many other aspects of your system built into the same code base, maybe the same process. So something can help us here is SOA. So what's that? Let's get the browser out again, search it up, SOA, lots of hits, some interesting things, maybe not quite relevant, but one of them is service-oriented architecture. So service-oriented architecture is breaking down our application into those individually composable parts that have their own responsibilities and enabling those different parts of our application to communicate and coordinate with one another via clear contracts or interfaces. And those individual aspects of our application have their own data and their own responsibilities. By splitting them up like this, it allows us to treat them separately, coming back to that principle I mentioned earlier, and scale them independently. Now, one of the ways you can take advantage of service-oriented architecture is by using serverless managed services provided by AWS to incorporate those features into your application. Whether you're looking for searching or logging or compute, you can incorporate these services in your application using their APIs, and you'll be able to get those features without having to build them yourself. One of those is the simple queuing service, and that can enable another really important paradigm, which is to loosely couple the different components. As you're breaking down the components of your application, if you loosely couple them, they can operate independently of one another and don't necessarily need to be scaled in lockstep. One can be sending messages to a queue, and the other one can be dealing with that as and when it can. Another paradigm that's really interesting and can help you here is event-driven computing. And you can implement event-driven computing using a service on AWS called Lambda. This enables you to define functions using your code written in Node.js or Java or Python or C#, and it will automatically load your code, run it, and unload it. And you only pay for that time that it was actually being computed. And it can be triggered based on events like changes to your S3 bucket, or changes to your DynamoDB database, or a Kinesis stream. So loose coupling can really set you free, and using serverless computing as well, because it can decouple the interactions between your systems, and it's something that you don't have to control or operate. It'll just automatically scale for you. Another paradigm that's really important to understand, you probably heard about already, is serverless web applications. So this is using something we've seen already, which is putting our static content in S3, caching it with CloudFront, and now we're supporting our dynamic content using Lambda. And we do that by putting the Amazon API gateway in front of it. And then Lambda can be responsible for doing functions for us. It can look after its data in a data store like DynamoDB. And that's almost all of our system now is actually completely serverless. We don't have to patch it, we don't have to scale it, we don't have to manage it in any way. AWS is going to take care of that for us. Now you might be asking though, where's the user interface? Where am I going to run the user interface part of my application in this scenario? Well, we're going back to that principle of two principles. One is moving that compute to the edge, closer to our end users, and also spreading the load around even further, this time by utilizing the compute in our users' browsers. We're running our application, our user interface code now, in our user's browser, using a single web page application, for example, with one of these frameworks, potentially. There's many popular frameworks to help you do that. So now if you can imagine your user interface running on your user's browser, either in their mobile device or on their desktop. Now I haven't drawn in this diagram the static content, but you just assume that's still there. I'm diving deeper now into the actual dynamic content and showing how we can break that down even further using microservices. So now we're getting down to having very distinct responsibilities for each component in our system. And that enables our teams who are building these to focus on those individual characteristics of that particular component of our application, the data that it's responsible for, and the way that it should be managed. Now you can instantiate that pattern using those services I've mentioned already. So using Lambda and API gateway, DynamoDB for the data store, for example, and you can build a microservices architecture that way. Now, if you're coming from a monolithic architecture background, you might be looking at that and saying, wow, this is going to get complex. In my real-world application, if I break my application down into those individual functional units, I'm going to have a lot of these. How am I going to manage it? And that is one of the downsides of the microservices architecture, which is why AWS has created a service called X-Ray, which enables you to get a visualization of your service call graph at any time and see what's happening in your application. It can help you to pinpoint issues and find out what different parts of your application are doing what. So this is an example. It's coming through an EC2 instance, doing some work, going to another EC2 instance, going back to DynamoDB, and a simple notification service. And we can see the time it's taking at each step. And we can dive deeper into each one of those and do a trace of our application and find out what's happening in the call stack. We can find out which part of our application is taking longer to do what. So these architectural concepts now are going to help us aspire to get past 1 million users. To do that, we're going to use all the things we've discussed. We're going to use multi-AZ, we're going to use load balancing, auto-scaling. Now, load balancing and auto-scaling are going to work together because as we scale out, the load balancer is going to not only keep track of the additional instances, but it's also going to keep track of what's healthy and what's not for us. We use service-oriented architecture and microservices to break down our application so we can spread that load out and manage it separately. We're going to offload the content and cache it as close to our end users as we can. And it's going to look something like this. Now, I've simplified this diagram a little bit. We're just seeing one availability zone, but you can imagine this across multiple availability zones. We've got our web tier being auto-scaled. We've got our caching, read replicas, master and slave. We're also using worker instances, which are taking work from a queue, loosely coupled from the rest of our system, doing work in the background for us. We're even using an internal load balancer to load balance services that are working in the back end to provide features of our application. We're using event-driven programming with Lambda, taking events from our DynamoDB and S3. And we're monitoring the whole thing with CloudWatch. We've even introduced some emailing with simple emailing service. If I add into that our serverless application development, we can start to move some of that functionality off of our servers that we have to manage and scale and operate onto servers we don't have to. So what are the next big steps? Well, if we want to go from 1 million to 5 million to 10 million, one of the things we're going to start to see is contention on our database. We're going to see the scale of our database start to be affected now in terms of both its compute and its storage. Now, if we chose Amazon Aurora earlier, this is going to help us deal with that. But depending on what scale we're looking at, we may need to take some action to help us deal with this contention on the database. We can do that with federation and sharding, and also taking more advantage of NoSQL. So federation, what that means is breaking our database tier down into individual components based on the domain. So for example, here we've got the forums database, still using that same pattern of master and slave with read replicas. And we're separating that out from our users database and our products database. So instead of having more than one database, now we've split them out. That's federation. We can also use sharding to define a partition of our application based on the users, for example, or the individual data that's in our application. We can have a partition key, and we can say all the users from A to L are going to be on one partition, one shard, and all the users from M to Z will be on another. And we'll use that same familiar pattern, master, slave, read replicas, to do that. We can also shift some of that functionality to NoSQL. So we're going to look into our data sets and into our database to look for opportunities to move that data onto NoSQL. Things that might lend itself well to NoSQL, like data that's not very schema intensive, name value pair type data, leaderboard scoring, really hot tables, or metadata type lookup type tables. Those are really good candidates for us to look at moving into NoSQL and further taking load off our relational database. All right, so let's do a quick review. We've got multi-AZ for our infrastructure. We're making use of self-scaling services. And whenever we do that, we're going to be able to scale our application up without having to take any action ourselves. We're going to build redundancy in at every level in our application. I've suggested you start with SQL and look at moving to NoSQL as it makes sense. We want to cache our content as close to our end users as possible and cache our requests whenever possible as well. We want to build automation into our service so we can provision it and re-provision it. As we refactor our application, we can do that automatically. We want to make good use of monitoring, metrics, and logging. Split our tiers of our application up. Split our application down using microservices and SOA. We use auto-scaling when we're ready for it. Once you get started with this and it becomes familiar to you, you may start incorporating that into your application much earlier on. Don't reinvent the wheel. And this is going to enable us to scale up and look at going beyond 10 million users, and really to infinity. So if we want to go beyond 10 million users, this is really a high-value problem at this stage. And those of you who had your hands up earlier would know that. You're going to have resources at your disposal to help you deal with this. So this is where you have the opportunity to look at more fine-tuning of your application, looking more into SOA and microservices, going from multi-AZ to multi-region. And you can use that automation to deploy your application automatically in different regions around the world and put it closer to your end users. And you could also look at custom solutions at this stage based on what your application behavior is. You're going to be able to do deep analysis of your entire stack. You may look at containers and serverless even more. So what's the next steps? Well, now it's over to you to put in practice what I've talked about today. There's lots of documentation for you to read in terms of architecture. There's solutions that we've pre-built and available to you either to use as a reference or a starting point. And we have quick starts to help you use many of these technologies. There's also a free tier if you're not using AWS today. You can take advantage of that to try out much of this without having to actually, without having to pay for it. Now keep in mind, you're not alone. We have forums. You can also subscribe to premium support and invite AWS support engineers to be part of your team. AWS support is very different to most support you're probably used to having, in that you can actually tap into that to ask questions about how should I do something? Or is this the right way to go about it? Not just it's broken, how do I fix it? You'd have an account manager potentially to help you, and a solutions architect like myself. So due to the pace of innovation and scaling on AWS is really an evolving story. So no matter where you are on that journey today, we'd like to help you scale up to your first 10 million users. Thank you.